But my name's Jesse Felter, and this is Tom Devine. Tom's going to be addressing any design-related issues and myself commissioning. Our intent of this presentation isn't to tell you how to commission. It's, if you're like me, I've been attending the presentations the last couple of days with the hopes of reinforcing what I already do. So hopefully by the end of this presentation, you have a little bit more confidence in what you're doing. So this may burn us, but we've decided to have a bullet point to discuss, and Tom will address it as a designer from the design perspective. And that same point I'll discuss from the commissioning perspective. And there'll be a few transitions. Hopefully it's not disorienting, but with this slide, this will be the first transition to Tom.
I'm Tom Devine, an electrical engineer, and I've been in the design business for about 20 years. And I'm going to address this question: why do we control lighting? The obvious answer is otherwise it's just on all the time and the lights burn out. Without control, we just have to leave them on, and that would burn a lot of extra energy as well without any real benefit. Second reason is to comply with code requirements. All of the energy codes require some kind of control for lighting, from say back in 2000 when we just had to make sure we had an on-off switch for things, to today where we have some very complex sets of lighting control requirements. As a design engineer, I am all about complying with code. I'm all about getting a permit. I'm all about getting a certificate of occupancy. These are the kinds of things where I look for what do we have to do when it comes to lighting controls. We'll particularly look at the IECC and look at ASHRAE 90.1, which are in force in most of the United States. California has a Title 24 of its own. Is anybody here practicing in California? There's plenty, and it is a very complex set of requirements. When we see it, you'll find that my reference to Title 24 is grayed out like an option you get on your computer when it's not going to let you do that. We're not going to be addressing Title 24 in detail because there's just way too much material. If we don't design to the level of control that those codes call for, we don't get a permit, or if we are lucky enough to get a permit, we don't get a certificate of occupancy at the end. We might want to satisfy other requirements that are kind of like a code. That might mean LEED or green globes, or it might be federal energy requirements that we have to do, say, under the EPACT of 2005. That might be also internal goals of the owner. The owner often has his own programs or initiatives. It might be that he wants to manage energy costs. It might be that he wants to just be a good corporate citizen, and he might have public relations goals with regard to his energy use and how he's treating the environment. And finally, we do this to improve the quality of the indoor environment. There's generally occupants that have more control over their workspaces are more satisfied with their environments than people that don't have that kind of control. There are a lot of studies that report higher levels of productivity and higher levels of satisfaction for people who have effective lighting controls versus people who don't. So this is, the question says, why control lighting? And obviously, otherwise the lights never go off. But another way to frame this question is, this is why we make the design choices that we make in setting up these systems and producing our documents for the building. Jesse?
So that same question, why control lighting from a commissioning perspective? Is it to check a lead box? Is it to save power, money? Is it a combination of both? Listed two bullet points just so we can further talk about this. But part of what we do is to understand what the client wants. How do we incorporate understanding as it relates to lighting controls and really any other commissioning system into what we do, into design? And the easy answer to that is the OPR, pre-design. We ask questions early on, and we incorporate that. We get that incorporated into the construction process and get the construction team on board with it. Here are two examples. I'm sure if you read these two, you can think of a dozen others. But what we'd like to do is be involved in pre-design, but oftentimes we're not. So we're thrown into a project during the construction phase. So we're presented with the challenge of finding information that we need to do our jobs to commission a system. But more importantly, that same information is being asked by the installer. We get involved in the project and we know the questions asked. The installer shows up and they unfortunately, for right or wrong, they have a budget and they're showing up to do their job and they're showing up and they want to leave as soon as it's done. We can avoid some of these scenarios, some other scenarios where we see people disable things that we commission by asking the questions early on and continuing to ask them. This is a rhetorical question. If you commission a system, is it better to not commission it or commission it as a default with no user-defined settings installed? In other words, if you've been asking for months, for a year, what do you want the time clock, time schedules to be set at, and you never get an answer to that, and you show up, you're asking the day before you show up, and you're on site, and you're looking at the installer, and you both know you don't have the information, do you commission it, or do you walk away? So that we can talk about that further afterwards, but it's just something to consider. Not to keep you in suspense, I certainly would commission it. It's better to commission something than to not. Proving something at a default setting, being able to verify a system operates, even if it's according to equipment submittal, is better than walking away. Walking away is never the answer. With this slide, we'll talk about evolution in codes.
The two primary codes that we'll talk about, the first one has just one on this slide, and that's the energy standard for buildings except low-rise residential buildings. That really kind of just trips off the tongue, doesn't it? ASHRAE 90.1. That first came out in 1975, and it came from the American Society of Heating and Refrigeration Engineers in response to the energy crisis of 1973. If anybody can remember that, I may be the only one in the room that does. I remember that I had to look at my license plate and see whether it was an odd or an even number and decide whether I could buy gas on that day or had to wait till tomorrow. I remember that. The International Energy Conservation Code, also we just call it the IECC, that came out for the first time in 2000. It came from the International Code Council, which is a consortium of different industry groups, particularly BOCA, that develops model energy codes or model building codes for jurisdictions to employ across the country. A lot of jurisdictions are using one of these two codes, almost all of them. California doesn't. It has its own. But they establish the minimum design and the construction efficiencies that are required for compliance for energy conservation. Below it, you'll see that I've got a little picture of California, or mention of California. It's Title 24, Part 6. It's specific to California. It's often seen as a bellwether for other codes. Things that happen in California, some of those things filter into the energy codes in the next iteration or the one after. For example, California 2013 has a whole lot of requirements about, California Title 24 2013 has a lot of requirements about functional testing of lighting controls that weren't in the previous version and aren't in ASHRAE or IECC. We may see some of that filter into these two codes as time passes. We may not see some of that. One of the great services that California does for the United States is try things early so the rest of the country doesn't have to implement a bad idea altogether at one time. California does a lot of things early, and this is one of them. It's much more demanding, a lot more specific than the IECC or than ASHRAE. We're not going to cover it in detail here because just to cover a little bit of California Title 24 in any detail would take up the entire time that we have. So we're going to let that go. and look at how ASHRAE 90.1 and IECC have evolved. The first edition of the IECC was in 2000. The only requirements it had for lighting controls were for manual control with bi-level switching for every space that was enclosed and automatic photocell switching for outdoor lights. The intent of the requirement for manual switching was just to make sure that occupants could select, for bi-level switching rather, is to make sure that occupants can select a level of light that works for their task without having to go to the full design level of lighting all the time. Before these requirements came around, it wasn't really unusual to see exterior lights burn all night and even all day and all night, especially prior to the rises in energy prices that we saw toward the latter part of the last century. 90.1 had the same requirement for bi-level switching in each controlled space, automatic photocells. It also had a requirement for separate controls for display, task, and non-visual lighting. Non-visual means for plant growth or for heating foods, keeping food warm. But all the codes love task lighting because that's a way to focus light in generally with a small fixture onto a specific task and not have to illuminate an entire space that may not even be in use at the time. At the same time, ASHRAE required, and I didn't get this on the slide, but ASHRAE 90.1, the 2001 version, required automatic controls for any buildings that were bigger than 5,000 square feet. And that was automatic shutoff, scheduled shutoff. And we'll see that that actually entered IECC in 2003. And we got light reduction controls to replace bi-level switching. It looks, that allows for general dimming instead of bi-level switching. It was specifically bi-level switching, they switched to general dimming. There wasn't any specific requirement for uniformity. You don't have to have dimming. You have, let's say this. It allowed general dimming to be the way you adjust light levels. Multiple level switching was still applicable, but there was no specific requirement for uniformity, which does come later. ASHRAE 90.1 added occupant sensing to satisfy its requirement for scheduled shutoff. That instead of a scheduled shutoff, you could use occupant sensing. In 2006, occupant sensing entered as a way to satisfy the requirement for automatic shutoff for IECC, and we got an exception to automatic shutoff for occupant safety. Now, normally, that's particularly important in industrial areas like central plants or places like that. And prior to this time, the energy codes didn't have any exception for occupant safety. Normally, almost any exception that I need that's reasonable, I can get from an AHJ if I can tie it to the safety of maintenance personnel or, say, even first responders. But oddly, this one I found the AHJs were very sticky on. I do recall having a central plant where I absolutely had to implement controls, lighting shutoff controls in a central plant before they would give me a permit. And the way I did it was to just say in the specs, which the AHJ didn't review, program them never to turn off. And the AHJ told me when he found out about that he would pretend he did not know. But I pointed out that the code did not require at the time for them to shut off, but that it only required that I have controls. There weren't really any changes in this version or any significant changes that I was able to tag in ASHRAE 90.1. In IECC 2009, we got daylight control zones. It didn't specifically call for automatic control, but it had requirements for separating daylit zones from, skylit zones from perimeter zones and separating perimeter zones, adjacent perimeter zones when they were not looking in the same direction. 2010, ASHRAE added functional testing. First time we saw functional testing in the energy codes. And it covered occupant sensors, programmable schedules, and daylight controls. And the requirement was that they're generally in proper working order, that they're in accordance with the contract documents, they're placed right, they time out at a reasonable time, and confirm, they required you to confirm that they were programmed to turn the lights off, that the controls would turn the lights off, from which I deduced that the guys at ASHRAE, after about 6 years, they got on to me about figuring out that I didn't have to actually let it turn the lights off. I just had to install the controls. Finally, and then confirm that photocell sensors actually work. 2012, we got a system commissioning section in IECC. We don't have that in ASHRAE. We have a requirement for functional testing, but IECC has a section dedicated to system commissioning that covers occupant sensors, schedule controllers, and daylight. It's a fairly detailed set of requirements. It's a short section. It looks about this long on the page, but it's got a lot more detail than the previous version. Now, ASHRAE gave us a very detailed list of requirements for those things, those same items. And we have to verify that they're in the right place, look in the right way, check the status indicators and make sure that they come on and off if they're provided. Check that HVAC doesn't trigger occupant sensors falsely. Make sure the time clocks are set right. Check the time switches program against the specs. Weekday schedules, observe that the battery is in place and that it's actually working if there's a battery backup. Verify manual override times, that they're not too long. Test the switches to make sure that they actually do turn off the lights. They just keep coming back to me. And my one trick that I played on the code guys in Houston back in 2004. Simulate unoccupied conditions and verify the shutoff, and on and on. The last one I see is verify the calibration, that calibration adjustments are accessible only to authorized personnel, which harkens to what Jesse said before about asking, have you seen occupants or building management disable some of these sensors and controls? And reading between the lines, what I see is that occupants aren't crazy about some of the lighting controls that they live with. And that they'll often try to adjust them or disable them if they can actually get to them. So ASHRAE 2013 requires that only authorized guys get a shot at that stuff. And finally, we're at IECC 2015. Let's see, the occupant sensors turn into vacancy sensors, or they activate the lighting at a 50% level or less, and then they also have manual controls. A vacancy sensor is an occupancy sensor that never turns the lights on. It only turns them off. That's kind of immune to interference from HVAC or by movement outside of the controlled area. I don't know about y'all, but I've got there's an office in my building that is unoccupied. There's not a person in it right now, but the light is never off, because anytime you pass it on your way to the restroom, the sensor spots you in the hallway and turns the lights on. A vacancy sensor is immune to that, so because it never turns the lights on. A person turns on the lights, the sensor turns them off after nobody moves for some period of time. It required that all the automatic controls have manual controls associated with them. I'm supposed to have a carriage return right here. The next line is multiple level control in daylight zones. That means the daylight zones can't just have a single 50% level or 70% level or 30%, but that they have to have several levels of control. It also calls for continuous dimming in classrooms and offices, labs, and library reading rooms. I didn't know there were so many library reading rooms that they merited a specific reference in there. ASHRAE requires at least 3 levels of daylight lighting. This actually, I think, is how the codes bias their selections toward LED lighting as opposed to fluorescent. There's a general view that fluorescent lighting is about as efficient as it will ever be, that it's been around for decades. We're not going to see improvements in its efficiency, whereas the belief about LED is it's still got a lot of headroom and can probably easily double in efficiency maybe before it starts to get close to the theoretical limits. LEDs, though, are typically more expensive for equivalent quality than fluorescents unless you're dimming. Dimming is almost cost-free. It almost comes with the package. you might pay a little tiny bit more for a dimming fixture than you would for a non-dimming LED. Whereas in a fluorescent, you have to buy a special ballast that costs a couple of $100 as opposed to something a lot cheaper. And that tends to make LED and fluorescent roughly competitive in terms of cost. While they're right now roughly equal in efficiency, the market, I think the energy codes want to favor LED and favor that development because they see a lot more potential in that regard. You want separate controls for all these other lighting, the different lighting that we talked about in ASHRAE in one of the previous versions. The design professional is supposed to attest now to system performance. That means that that's me. I have to eventually, before final inspection, I have to provide evidence to the AHJ that the system has been tested in accordance with the codes. Now, in the jurisdiction where I practice, they adopted this code in November last year. So we haven't seen a large building that was permitted under IECC 2015 go all the way to completion and look for a certificate of occupancy. But so it's not clear at this time in Houston what form this will take. It might be something as simple as a ComCheck form, or it could be something a lot more complex. But the AHJ is going to be looking to me to provide some evidence of that, at least per the code. It has detailed requirements for occupancy sensors, time switch controls, daylight sensing controls, and the testing requirements are substantially like the ASHRAE 2013, so we're not going to go through them all again. And finally, and this one's interesting to people who are electrical contractors, that 10% of the occupancy sensor controls have to be tested, either all of them or 10% of the controls, at least 7, depending on the size of the project. If you're working on a large project, you'll be doing 10%. And if 30% of them fail, you have to test every single one. 30% is a fairly high failure rate. Now, this doesn't necessarily mean that they don't work at all. It just means they don't work like they're supposed to. If in testing you find 30% of them not up to specs, either by aiming, location, whatever, then you have to test them all. And that's going from 10% testing to 100% testing, say in a 1 million square foot building, is a substantial penalty. And when it's not certain who's going to wind up paying for that, I suspect that the contracts will ultimately be written that the contractor will have to take that responsibility. So I think that's something that we'll see, and we'll certainly start seeing arguments later about who pays. We're not going to go any further. There is an ASHRAE 2016. It's out, but it hasn't yet been declared by the Secretary of Energy to be more efficient than the previous version, and that isn't scheduled to happen until about September of this year. IECC has that certification from the Secretary of Energy, and that's why we have seen a lot of activity about it now, is that when the Secretary of Energy makes that declaration, federal law requires various jurisdictions to either adopt the code, adopt one that they claim is better, more efficient, or tell the reason why. So this is how they've evolved over time. And then I'm going to show this last thing. This is an imprecise measurement of the complexity. This is nothing but how many words we have about, I was about to walk away from my microphone, about total requirements for lighting control, and then in blue, and then in red, and on the red scale, functional testing in the IECC. We didn't see anything until 2009 for functional testing in IECC, but it went up pretty sharply after that. I mean, 600 words isn't much, but at the rate it's going to change quite rapidly. We've got an exponential curve here. And if we looked at California Title 24 and its requirements for functional testing, if I plotted them on this graph, they would be up on the top of the second floor. They're about 10,000 words. Now, words don't mean complexity, but it's certainly not going to be complex by virtue of having fewer words.
So Tom took us through the evolution of code, and we're going to talk about the evolution of lighting controls. So we now have an idea when we show up to commission or when we're doing a design review, what led to some of those choices. Why is there control in this space? Why is the zone this way? Why is there an occupancy sensor here and not in this area? If you don't know that, there's certainly been enough resources provided. The codes and standards are used fairly consistently. So what do we mean by evolution of lighting controls? How we test lighting controls today isn't necessarily how we tested it a year ago, 5 years ago. Is that because technology's become more complicated? No, I would make the argument not so much. An occupancy sensor that you see today, or a time clock, or an astronomical feature, is essentially the same type of technology that's existed last 10 years. What's become more complicated and why we see a trend in a more complicated testing is the implementation of that older technology. It's the owner wanting more out of existing equipment. It's essentially hardware versus software. When we see lighting control systems now, the more complicated systems integrate power shades. The owner wants to know not who, but how many times somebody goes in that space. Wants to be able to access through a heads-up display at real time what lights are on in his building or her building. They want to be able to control and modify. And having not dumb systems, but less involved systems, less information is a thing of the past now. There's certainly still an application for it. More complicated doesn't mean better, but this is the trend. Tom did a good job explaining code, how we see a trend of it becoming more complex, and we can only expect the industry to continue to follow that. So the next few slides, this is where we actually meet the title, where we discuss commissioning of lighting controls. As I said before, my intention is not to instruct or tell you. I'm sorry, that's the commissioner and me. I'm not directing. We'll talk about how you could potentially test some of these systems. If you have a question, certainly raise a hand and we'll talk about it more. But most audience is familiar with this. So I'm not going to enlighten anybody by saying, providing information on how to test a daylight harvesting system. If anything, it'll be comical to hear how we all approach doing this, or at least myself. So at the previous slide, we just listed some of the components of lighting controls, and we're not going to talk about them all, just to stay within the time frame. But I did pick a few to discuss, and here are the next, some of the slides we'll talk about these systems. I'm not quite sure why there's a star by daylight harvesting. It doesn't mean it's any more important than anything else. It's just a typo, so please overlook that. So daylight harvesting, the first slide. When we show up to test, unfortunately, there's not a section at the end of the specs for field quality that goes into detail how testing should be done. And it's a challenge when we are talking to the installer and we say we need to show up and commission, and then they say we're ready. What does ready mean to people? And it's a constant challenge to define not our expectations, but the client's expectations, the owners. So we're always fighting that fight up until the day we show up to functionally test. And I'm using combative terminology. At some point, you're always trying to develop a team atmosphere. Showing up with somebody that's an adversary, it's going to be a long day. And I'll talk about that more when we discuss the commissioning process. There's a way that I've found. I'm sure it's no secret, but a lot of us have incorporated into how we commission. So how do you test a daylight harvesting system? That really could begin during the pre-design. You need to know what the lighting level's set at, any dead band, any type of user information. And I alluded to before, if you show up without that information, what do? You certainly can still test it, and you can document how it's installed. And that's a lot better than nothing. So what do you document? You're essentially providing a report to the owner saying, here, Mr. and Mrs. Owner, this is the system that you have installed. If you would like it to be customized to what you want, maybe training's the last proverbial bite at the apple to get the representative from the facility and the tech in the same space to say, yeah, I want lights to turn on and off at this time. But specifically for daylight harvesting, this is just more for comedy. There's no, first time I did Expo, I was kind of hoping to walk through there and see somebody with, commissioning testing equipment for, electrical folks, daylight harvesting. I see a lot of mechanical equipment out there, but nothing for people like me. So what do I do when I test daylight harvesting? It involves walking around, looking for electrical tape or a cup or a stick, and covering up a sensor, standing on a chair. There's nothing complicated to it, but I don't have anything in my bag that's a magic tool. And I'm sure we all do something different to go on the job site. That's just something to think about. It would be nice if we showed up to an expo one day and there was some type of extension pole with a cup that I don't have to tape and make every time. This picture, I included intentionally. This is more of just a quick story. You can walk outside a building with power shades fairly easy and see what's scheduled properly, what's not. If the shades are incorporated into daylight harvesting photocells, you can tell what's happening and what's not. So if we're outside this building and we see two, I don't know if you can see in the back of the room, but when these two shades are down, the rest of them are open, you at least ask the question, why are those down? Just a little background, everything behind those windows, it's all consistent, open office space, nothing special about those two windows as opposed to the rest of them. So this began my discussion with the installer, and started out asking questions that I'm sure y'all do this too, that you already know the answer to get an idea. It quickly became a heated discussion. I'd like to think no fault of my own. But at the end of the discussion, I just simply put it to them, why are these down and the rest of them open? And the response was, there's multiple light sources. And it took me a second, and I had to readjust how I was approaching this contractor, but essentially they were telling me there was two suns outside, and I, from then on, realized it was going to be a difficult time. But we did get this done, and it ended up turning this person who was an adversary into an ally at the end. So here's another aspect of lighting controls. Again, we're not going to go into too much detail, but I highlight it here just because this is how we break up commissioning of lighting controls. Depending on the complexity of the system, essentially break it up into several components. First, you can consider a local control. You walk into a space. It's what your motion, your direct presence causes the lighting to do. Occupancy sensors, vacancy, presence would turn on and off lights. So we do that. That's how we organize our functional testing. Walk into a space, and that's how we control it. The other form would be automated control, sweeping on and off lights as a whole and area zones. So we really break it up into local, where you physically need to be present, and then kind of not a catch-all, but the other type of overall themed lighting control where you sweep large areas off and on.
Yeah, these are the kinds of things we do and during the design process to decide what we do about lighting controls and what we have to do. We will often start with verifying the code requirements with the authority having jurisdiction, especially a new, relatively untested code like IECC 2015. It's only been enforced in my jurisdiction for about 6 months. No large buildings have come to fruition that were permitted after November. We certainly haven't had time to build a, say, 1 million square foot structure and then fit it out. So until we know more about how these requirements actually shake out in practice, it's important to get clarity with the AHJ about the extent to which they want to enforce things and about the mechanisms that they intend to use to make sure that they're enforced. For example, the rule that I will provide evidence that the testing has been done in accordance with the codes. It's not certain how I will provide that evidence, whether they expect me to witness tests, review documents, or just provide a document that maybe Jesse put together. Not certain whether he will want me to seal those documents, in which case, if he does, I have to directly supervise, at least have substantial input into how they're developed. Next, to determine the owner's requirements, he may have requirements in excess of code or in addition to code. He may want to be a lead building. He may want to have a certain appearance of the building in after hours time. Then the next thing is, obviously, if we have two inputs, an AHJ and an owner, there are going to be conflicts between them, so we have to resolve those conflicts between the owner's requirements and the code requirements. And then there's bound to be conflicts in cost. If the owner often wants a very sophisticated control system, but he's not really wanting to pay out very much money for it, so we have to find that happy medium. Typically, there are plenty of conflicts to resolve. We develop a lighting control strategy and we select a technology, and depending on the size of the building and the complexity of the system, that might be standard hardwired contactors with a limited dimming, limited automatic dimming, or level selection. Or it might be wireless systems, it might be a dolly system, it might be some combination of those. We'll have to identify the daylight zones and boundaries of those zones. We need to, of course, work with the architect. They depend on the height of the windows and distance from the perimeter, and it can get complicated. The requirements are pretty detailed, and it's not clear how thoroughly the AHJ is going to pore over the results or what results he's going to pore over. I don't see him coming out late at night, shining flashlights up and seeing what happens. I've seen him come out late at night to make sure that my life safety lighting was good, but I don't see him coming out for this. Certainly not as regularly as he does for the other. There will be a lot of the design details in the specs as opposed to on the drawings. And the AHJ, in my jurisdiction at least, doesn't ever review the specs. He only looks at the plans. We'll develop the specifications in the drawings as a matter of course. The next thing is that we'll do kind of towards the end of this process, we'll verify that the submitted equipment gives us the required functions, the functions that we required in the specs and the functions that the code requires. Because we, the design team, ultimately have to provide that evidence that the system has been tested according to code. That brings us some duties that have traditionally, to some extent, been in Jesse's province, in the province of the commissioning agent, that he will verify in the early design stages that the system is commissionable, because we have to verify that it's testable. We'll need to come up with a strategy for how we test things like daylight harvesting, and we need that in advance. That'll probably lead us as designers to specify that a test plan comes with it, comes with the submittal for the equipment. We could sit in our offices, engineers can sit in our offices and think of clever ways to test lighting systems, but anybody who's ever done it knows that schemes that were cooked up by eggheads in air-conditioned rooms often don't work exactly as well out in the field. So I'd like to see, I definitely want to see the contractor's input on how that's done, and it probably will be all three of us. The design engineer is going to look for code compliance, the commissioning engineers, or commissioning team or agent is going to look for commissionability, testability, and that it's tested for function. And the contractor's going to have to tell us what he can do and what's reasonable for him to do.
So why versus how for commissioning? The beginning part of this presentation, we elaborated on the why. And here is the how. All right. So the overall purpose of this presentation is to discuss lighting control, the commissioning of lighting controls, not necessarily go into detail of the commissioning process. These slides are to discuss how lighting controls relates to this aspect of commissioning, but I'll tell you right now, it's no different than any other system we would commission. How we approach commissioning of lighting controls is a repeatable, rinse and repeat process that we can apply to anything. First and foremost, we want to get information as soon as possible, incorporate into a plan, and make sure it's accurate. So here are some of the slides that we'll discuss, and I'll tell you right now, a couple of them are out of order towards the end, but we'll, again, stay mile high. I'm not going to read these to you. How does the OPR apply to lighting controls? Just like we said, it's the questions we ask early help us with functional testing at the end. If you can ask the owner, what do you want this schedule to be at? What do you want? What is the purpose of this space? Where do you want occupancy sensors, time delays? Get that, ask that question early. Often you may not get the answer, but you can at least document that you've been asking. And that is an important part of what we do. BOD, another pre-designed document. OPR, information will transition into BOD information, and from there we start incorporating the owner's intent into design. How do we do that? The next step ideally would be to start including functional testing, the owner's expectations, and our expectations into the specs. So when we say we're going to functionally test lighting controls, the installer knows I need to have a day for it. He or she knows that I don't simply need to pay for the tech to come out for one day. They know that they need to be out there for that one day, be it startup or training, and time for commissioning. What we're trying to do early on is to answer that question, why am I doing this, by the installer? We've all heard it, same answer. And it's hopefully not because I say so, it's because you've been contractually obligated to. And it's really easy to point to the specs and read it off to them and say, this is why, and then ask them, why haven't you read the specs? But maybe in your head, let's try to keep it non-combative. Can continue on with the commissioning plans slide, as the previous ones are particularly poignant. So the commissioning plan, how many people make a commissioning plan? A lot of people. So when you see this slide, whether you enjoy making CX plans, sometimes they're a burden. You could have been working on one late last night. You could be thinking about one right now. But we're always trying to evolve how we do things. How you made a commissioning plan a year ago isn't how you're going to do it tomorrow. But the overall ethos for it is to convey owner intent, design requirements, and give a clear direction or a map to the installer. This is what we expect. I've heard it referred to as an open book test. We want to get that in the hand of the installer so they know what to expect. Specifications probably should have been served better if it was a previous slide. But this is, as we discussed earlier, no different for lighting controls, commissioning of the building of this document as any other system. We want to incorporate our expectations into the specs as soon as possible. Same thing with check sheets. This is really where you get to know the contractor, where you get to know the players, the equipment. You're showing up on site and touching, not physically touching, but you're present. You're making a presence. You're becoming familiar with the history and more importantly, you're documenting installation. How is that beneficial? It's more than words. It's simply being able to see a history of an piece of equipment that when you turn in your final report, 5 years, 10 years down the road, facility operations continually has an issue with the piece of equipment. They can turn to the commissioning document and see an actual history of, well, during installation, there was moisture in this space and they had to replace this, and it gave them issues during training. And that's valuable information to somebody who's operating a facility. They can go back and see, they can see what happened and answer their questions. Just going to stay a mile high. We're running out of time. Functional testing, again, no different for lighting controls. Define your system early, get it incorporated into your plan. Systems manual is a good place for facility to go to ask their questions after everybody's left. Get their questions answered after everybody's left. I apologize for the brevity of those slides. Simply put, it's no different for lighting controls commissioning than any other system. But we can certainly talk about this more. And that concludes our presentation. And this